Hey guys, we're looking at 3.2, lesson 1 of 3, overlapping and disjoint for integrated math 2B. So on slide 1, go ahead and toggle. It's kind of cute, the little rain clouds come out. So go ahead and toggle, let me know how you're feeling today, and then type in this space over here if you'd like to share more about why you're feeling the way you are. All right, we'll click the next button. So I had kind of two things here. I was gonna have us. It didn't end up working, so we're gonna skip slide 2 and 3. It was supposed to say cats only, dogs only, but for some reason the coding was not coding. So skip this slide, skip this slide. We're gonna instead do this slide here on slide 4. This is, again, a recorded lesson, so you're following along in Desmos, so you should be on slide 4. Again, skipping those other 2 warm-up slides since the coding did not really pan out the way I thought it would. So we're here. Go ahead and drop a dot. Where are you for these 2 questions? So I encourage you to use like a really big dot. If we were in class, I'd give you time. We do an overlay, right, showing all of your work on one slide to see where everyone's at. But because this is a recording, kind of hard to do that. So go ahead and just drag a dot, drop a dot where you're at, and we'll go over this, what you guys have shared next time we meet. So which one would you prefer? Cats only, dogs only, cats and dogs, or none of the above, right? So we're looking at a Venn diagram here. And then for the second Venn diagram, you're answering if you're a freshman in high school versus if you're a senior in high school. All right, so go ahead and pause this video, drag, drop a dot where you're at, and then we'll go from there. All right, assuming you have paused, you're ready to check. So let's see. So for the first one, it could be cats only. You could be preferring dogs and cats, only dogs. Or if you are outside of the Venn diagram, anywhere outside of those 2 overlapping circles, it's for no cats and dogs. Maybe you have a different animal preference. For me, I love dogs. No shade against cats. There's only been like 1 cat that I've met that's like nice. All the other ones, I think they know I'm like a dog person and they just like don't. They're just like not into it. They don't like me. So it's fine. Dogs all the way for me. That's my vote. Second one, if you're a freshman or a senior, if you are neither, right? Maybe I should have changed it to be if you are freshman, sophomore, like a lower classman or upperclassman, or you're junior, senior, right? That would have made a little bit more sense than just specifically freshman and senior. So sorry, sophomores and juniors, for this poll. I guess you were out here on the outskirts. You're like, nope, I'm neither. So in this Venn diagram, there is a middle space where these 2 overlap, and I wanted us to talk about this, but again, this is a recording, so it's really just going to be me talking to myself about this middle space. So with Venn diagrams where there's overlap, like with the cats and dogs, we had like in set A on the left, cats only is your preference. Set B on the right was dogs only as your preference. And then where it overlaps, you like kind of have neither preference. You kind of like both animals. For here, first set is you're a freshman in high school. Second set is you're a senior in high school. And there's that middle ground there. But can a student be both a freshman and a senior? I know that you can do accelerated programs in high school, but that's like really advanced. To do all of 4 years in 1 year, I don't even think that's legal. Like that's like too much on your brain. So in this case, the Venn diagram is actually incorrect. These should be 2 separate events. There can't be an overlap. There can't be that middle ground because we can't have a student that is both a freshman and a senior, right? Or even like with age, if you're comparing ages for freshmen and seniors, you're comparing students that are 14 versus students that are 18. You can't have a student that is both 14 years old and also 18. right? No, like that's not their age. They can't be both at the same time. So in this case, we're going to find out what these vocabulary words mean. Again, this is a recording. So because this is a recording, we will update our notes next time I see you guys in class. So don't worry about it. I know there's a little camera button. You're like ready to go. Well, we're gonna do this during class. So disjoint versus overlapping. So two events are called disjoint when they have no outcomes in common. So that's like the freshman versus senior. And again, I'm going to draw this as two separate circles. So we needed to, and this looks like really crazy. There's a lot of lines here, but these are supposed to be two separate circles. We cannot have that middle overlap because it's not possible to be both a freshman and a senior, right? And my little thinking thought bubble over here question, can these events happen at the same time? Can you be both a freshman and a senior? No. So when two events have no outcomes, they do not share an outcome, they are separate events. I'm going to even put that in here. Anything that I'm writing down to, make sure you're copying in your Desmos. So these are separate events. When it is disjoint, two completely opposite events do not relate. Versus our next one, overlapping, if they have one or more outcomes in common. So you could prefer only dogs, you could prefer only cats, or you could meet in the middle and you like cats and dogs, right? That's overlap. You could be both. You don't have to be either one because there is overlap there. So overlap is when they have one or more outcomes in common. So I'm going to say it can be both. So can include both. So it's kind of like the disjoint. These are our only two options. They're completely separate. They don't overlap. Versus an overlapping events where, like as the name suggests, they're overlapping. We can have the two separate events, but you could also meet in the middle and have a scenario where it's both. So it's either both or it's neither. It's one or the other. All right. Again, if we were in class, I'd add this to your notes, but we will do that later. We're on now slide 6. So normally in class, you're refreshing your Desmos. If you do not see slide 6, make sure you're clicking on that next button to jump to slide 6. We're going to try this out. Let's see what happens. So a 6-sided dice is rolled. Okay. Draw a Venn diagram that relates these two events and decide whether the events are disjoint or overlapping. Okay, so a dice is rolled. Draw a Venn diagram for this event. Okay, so what's the events? So event A is that we roll an even number. Event B is that we roll a prime number. So I'm just going to get our Venn diagram ready. We've got event A, which is even. Event A is even. Actually, before we draw it, we need to know if it's disjoint or overlapping. So hold on, before we need to know which kind of circle are we drawing. So let's start with the sample space. Sample space. Remember, sample spaces are total possible outcomes. The grand total outcomes for a dice rolled, 6-sided. We could roll a 1, a 2, a 3, 4, 5, or a 6. And that's it. Those are all the options. And I'm going to color code, just getting us ready here. I'm going to have even be green. So all of my even numbers, 2, 4, and 6. Okay. And now I'm going to highlight all of the prime numbers. That is 1, 3, 5, and there's actually one more. It could also include 2. Ooh, so we just circled the number 2 can be both. It can be both even and it's also prime. So it seems like this is going to be an overlapping event because as I'm categorizing this, getting this ready for our Venn diagram, I'm seeing here the number 2 fits both criteria. It is both even and it's also a prime number. So by knowing this, overlapping, okay, this is where the 2 are going to intersect. I'm going to try my best here to draw a circle. Yikes. Event B is that they are prime. Prime. Draw another circle. Beautiful. All right, so even numbers. That's all the green ones that I circled, that I highlighted, excuse me. So that was the number 4, the number 6, and then again, that number 2 is a combination of the two. It is both even, and it is also prime as well. So I'm going to do a double highlight for number 2. What else do we know that's prime? That was 1, 3, and 5. All right, so there we go. Let's just make sure we got this. We're good. 6-sided dice is roll. Draw the Venn diagram that relates the two events. Decide if they are disjoint or overlapping. They're overlapping, and that's it. Later, we'll see how to then use this to find the probability of an event occurring. But for right now, we're just getting the basics of drawing a Venn diagram. So again, make sure on your Desmos, you have something similar. This is what I want to see again for your exam with showing your work, is the sample space listed out. If you don't want to color code, you could have like maybe even numbers are boxed, prime numbers are underlined, some way to organize to show how it's going to match up. But again, that even number 2 is both even and prime, so it's in that overlapping area. Okay. Wait a minute. Hold on. Oh, sorry. I forgot. Okay, we can skip this slide. I ended up actually drawing it out for you. I forgot that I made it all nice, but that's pretty sad. It's okay. I mean, I feel like, for the best I could do, that's okay. Like we can see it's a Venn diagram. But anyhow, so we're gonna skip slide 7. I forgot that was there. That's on me. Go ahead and try this on your own. Same idea, you're drawing that Venn diagram between these two events with the dice being rolled. But before we dive into draw, we need to figure out, are these events disjoint, where they do not relate, they are separate events, or are they overlapping where we could have a common ground? We could have an answer that works for both. So let's see. Event A, the number rolled is a 2 or 4. And event B is the number rolled is an odd number. So again, this is for a dice. So our first step, I'm going to help you out, is writing that sample space, which is numbers 1 through 6. 4, 5, and 6. And then from that, highlight, color code, what matches with event A, what matches with event B. And then, okay, once we've got it underlined, highlighted, okay, now is this disjoint or overlapping? Because if it's disjoint, we're going to draw 2 separate circles. If it's overlapping our Venn diagram, they're going to intersect. So let's have you pause this recording, pause the video, try this on your own, and then we'll go over it in just a moment. All right, assuming you have paused, you're ready to check your answer. Let's see what's happening here. So, sample space, okay. Let's color code. Number rolled is a 2 or a 4. Okay, 2 or a 4. And then the number rolled is odd. So an odd number, not divisible by 2. It's not even. So 1, 3, and 5. And that's it. So it looks like there's no overlap, right? There wasn't a number that fit both categories. They're separate. So because these are separate events, I'm going to rewrite that too. Separate events. Because they are separate events, this is disjoint. So we're going to write this out. This time I'm going to use the text tool. We'll make this look pretty. So event A was rolling a 2 or 4. And then I'll use that text tool for event B, which was rolling an odd number. These are separate events. So because this is, again, disjoint, your circles cannot overlap. So if you drew it out with them overlapping, make sure you use that eraser tool and go ahead and update on your Desmos. So event A was just rolling either a 2 or a 4. Event B, rolling an odd number, is 1, 3, or 5. And that was it. This is our Venn diagram showing us comparing these two events. So again, these two events are disjointed. They are not connected because we can't roll a 2 or 4 that's also an odd number, right? Because that's like the definition of odd is meaning it's not even, not divisible by 2. So it doesn't work. Separate events, just like you can't be a freshman and also a senior. They're separate events, All right. Again, this is a recording, so we can't add this to our notes, unfortunately, but we will update next time we're in class. I've got on slide 9, if you want to set a timer for 2 minutes, take a little rest, grab some water. You can play your own music now. You don't have to listen to my lo-fi. 2 minutes, and then, so you can pause the video. All right, if you took your brain break, all right, keep rolling. So now on this slide, I was going to have you work with a partner, but this is a recording. So you guys lucked out that you're not working with a partner. Try this on your own. So again, you guys are going to be sick of looking at dice for today. But yet again, a 6-sided dice is rolled. Event A is that the number is even. Event B is that the number is prime. Find. You're probably thinking, wait, didn't we already do this? Hold on. Even and prime. Let's go back. We already did this. Oh my. I'm going to write it down and I'm going to copy it on that other paper. Please hold. Please hold. So it was even, prime. We already did this. They are overlapping. We had 4, 6, 2, 1, 3, 5. Okay. So we already did this. We're going to go ahead and add that information over here on slide 10. Just a reminder. So we had even and we had prime. And now we're taking this information, we're going to be using this diagram to now find that probability. So even number is 4, 6, 2, prime is 1, 3, and 5. Okay, that's what we had on the as a class. So now go ahead and try this on your own. You can pause, find the probability that event A happens, the probability that event B happens, and then lastly, the probability that event A and B occur. All right, so go ahead and pause the video, try this on your own, and then we'll go over it. All right, so assuming you've got an answer, you've taken the time. If not, again, pause. We're going to check your work. So remember, when we're finding the probability of a number, we need to rewrite our formula. And it was the number of favorable outcomes divided by the total number of outcomes. So the probability that event A occurs, event A was that an even is rolled. So we're looking at everything inside the even category. There are 3 numbers. Remember, this is a standard dice. It has 6 sides. That was our sample space, right? Or our total number of outcomes. We're getting a fraction together here. So the number of favorable outcomes, if we roll an even number, there are 3 numbers that are even for a 6-sided dice. We can simplify, divide by 3. That will give us 1/2. So as a probability, 1/2, 0.5, this is a 50% chance that if you roll a dice, it's going to land on an even number. All right. So if you don't have that, again, pause the video and update as you go. Probability of event B occurring is looking at a prime number. So we're going to look at the prime Venn diagram. And there are 1, 2, 3, 4 outcomes that are prime, 4 that are prime. Yep. 1, 2, 3, 4. Yeah. I was like, hold on. Yep. So there are 4 outcomes divided by 6. We can factor out a 2 from the top and bottom. Maybe. There we go. Took me a minute there. That's going to give us 2/3. 2/3 in the calculator. 2 divided by 3 is 0.6 repeating. So that is going to be about 67% chance. So you have a 67% chance that if you roll a dice, that it will land on a prime number. Again, that a prime number is a number that its only multiples are itself and 1. It's not composite. Like the number 4, if we did a factor tree, you could do 2 and 2 and also 4 and 1, or 6. 2 times 3 gives you 6. But for 2, the only way we can multiply it is itself and 1, itself and 1, itself and 1, itself and 1. So that's why they are, again, prime numbers. I think I forgot to mention that earlier. Prime numbers, only multiples are itself and 1. Lastly, probability of A and B. Now we're looking at this middle ground. The probability that a number is both. So probability that a number is both. That a number is both even and also prime. And that was our number 2. So that means there is one favorable outcome. There's only one number that was both divided by the 6 total. Let's see, 1 divided by 6 is going to be about 17% chance. It's very small. Very small. Remember, this is a scale of 100%. 100%, it is certain to happen. Remember, it's a scale from 0% to 100%. 0% chance, it is impossible. 100% chance, it is certain to occur. 17%, probably not going to happen, right? 50 could go either way. 67, it's likely that your number will be prime. It's likely. All right. Again, if we were in class, we'd add this to our notes. We'll add this to our notes next time. All right. I've got some work here. I need to double check for probability of B because I had here that it was 1/2. I might have grabbed the wrong one. I'll circle back to that because we got 4/6. I might come back. I'll come back to that to check. I'll keep you guys posted if this is right or wrong. But go ahead and let me know, ignoring that. How did you do on that one? This is like our check-in. Did you get it? You're pretty close, about 50-50, not quite, not even close. Go ahead and let me know where you're at on slide 11. Slide 12 is blank. We're going to skip it. On slide 13, go ahead and let me know, drag that smiley face. How confident are you feeling about understanding the word disjoint and overlapping? Were you kind of like knew one a little more than the other one, kind of about the same, understood both, right? Whatever, however you're at. And then if you have any specific questions for me, go ahead and type it here on this slide. The remainder of our slides are going to be locked. You won't be able to access them while you're watching this video, and that's okay. That's intentional. In our next lesson, next day, we're going to finish up this slideshow. So again, make sure you're showing all of your work because I will be checking and giving points to those of you who are working, who showed work in Desmos, annotating your slides just like we did. And if you have a specific question about a topic, remember to send me a Canvas inbox message. All right, that's all. And don't forget your homework in Khan Academy. And I'll see you guys later. Bye.